Hi Chem Peeps, this is video 3 in a series on gas laws. We're going to talk about Graham's Law of Diffusion. And the one thing I tell my students that I want them to remember is that as the molar mass of the gas increases, its rate of diffusion decreases. In other words, it travels lesser distance than maybe another gas that is lighter. So that's an important concept to remember. Look at the formula. We have rate 1, that's the rate of gas 1, divided by the rate of gas 2 is equal to the square root of the mass of gas 2 over the mass of gas 1. And so if we look at the first problem set, it says, what is the relative rate of diffusion? In other words, we're trying to find the left side of the equation here of two gases who have a density of, and they list them. Now, I apologize real quickly. I'm having trouble with some software. These should all be superscripted, but we can still solve the problem once we know that that's what that means there. So let's go ahead and set up the problem. I'm going to make the 1.33 my gas, my gas 2. And I'll explain why I arbitrarily did that. And then the other one to be gas 1. Gas 2 is heavier in mass. And so when I plug it into my formula here under the square root sign, it's going to be a larger number divided by a smaller number. So we're going to find rate 1 over rate 2 is equal to the square root. And I know it says molar mass, but we can go ahead and use density. So gas 2 is 1.33 times 10 to the minus 3 grams per centimeter cubed, divided by gas 1's density 1.165 times 10 to the minus 3 grams per centimeter cubed. Now I'm going to go ahead and simplify the right side of the equation, and I get the gas of 1, the rate of 1 over the rate of 2 is equal to the square root of 1.14. Doing its own thing, 1.14, and if I take the square root of that, it is going to be 1.07. So basically what it's saying is the ratio of 1 to 2 is 1.07, but if I wanted to know a relative rate for each of them, if I divide this by 1, it's still 1.07. So gas 1 rate would be 1.07, and gas 2 would be 1. Now, does that make sense? Coming back to what I had stated here, as the mass or the density increases, is it moving slower? Yeah, the gas 2, which we said had the higher density, is moving less distance, or 1 compared to 1.07. So that this all works out. So let's go ahead and solve problem set number 2. Let me change my color here. So in the second one, it says find the density of a gas which diffuses at a rate of 1.1 to 16 times greater than that of one with a density of 1.78 times 10 to the negative third grams per centimeter cubed. And I do believe, I'm looking at this, this should be 1.16. It shouldn't be a proportion. So that's the rate of one of them. And that's going to be gas 1. So I'm going to say this is the rate of 1. And since it's greater, it should have the lower mass. And we will find that out when we solve the problem. So let's go ahead and set this problem set up. I'm so close to the edge there that it doesn't want to write. Finish. Okay, so if we set this up, if gas 1 is 1.16, the other one is going to just be a 1. Okay, so if I divide that, it's still 1.16. So that's gas rate 1 over gas rate 2 is equal to the square root. Now I need the mass of 2, which they give us is 1.78 times 10 to the minus third grams per centimeter cubed. I guess it's density, but can use it in lieu of mass, over mass 1. Now, to solve for something that's under the square root, we are going to have to square the entire problem. And so when we do that, we are going to get 1.35 over 1, which I'm not going to write the 1 anymore, is equal to 1.78 times 10 to the minus third, and that's over mass 1. So assuming this is over 1, if I take this side times this top times the other bottom and set it equal to the other top times the other bottom, I am going to get 1.35 mass of 1 is equal to 1.78 times 10 to the minus third. And mass 1 is going to come out to be 1.32 times 10 to the minus 3 grams per centimeter cubed. Now, is this mass lower than the other one? It is indeed. So this makes sense that we did the problem correctly. I hope this helps you with Graham's Law of Diffusion. Leave me a comment or a like. If you need more examples or you need more explanations, let me know. You can find more information on gas laws on TikTok and YouTube at Chem's Chem Chats, and I'll check you out in the next video.